Good morning, everyone. I hope I am fairly audible to you guys. Okay. So I just want हमने लास्ट लेक्चर में क्या किया था? That was, I guess, done in yesterday's lecture in the division 2 और division 1 में लास्टली क्या किया था हमने? डिवीजन 1 में क्या किया था लास्ट में? I hope everyone is awake. Anyone from division 1? Anyone from division 1? कोई नहीं है? No one from division 1? ओके सो अगर किसी को रिस्पॉन्स नहीं देना डिवीजन 1 में से तो दैट्स फाइन बाय मी. Okay, so moving towards, again, I'm asking that I hope my voice is loud and clear.
Yes, sir.
Anyone at least can reply in the chat.
Yes, sir. Sir, last time I think we completed till effective access memory time.
Are you talking about division 1?
Yes, sir.
Effective memory access time. तो ठीक है, मुझे जहाँ तक याद है हमने शायद डेफिनेशन भी देखी थी पेज रिप्लेसमेंट एल्गोरिथम की. Okay, not an issue. We have so today we are going to see. Let me just summarize कि इसमें क्या हुआ है, right? Just a second, let me share my screen. मुझे जहाँ तक याद है आपका इतना हुआ है.
Yes, sir. Yes, sir. We have done with page replacement algorithm.
मतलब हमने सिर्फ उसका थियरी देखा है. दैट्स व्हाट इज. ओके, लेट मी समराइज. Okay, we have seen effective memory address. Okay, and that too using that translation look aside buffer. Okay, हमने ये सब देखा होगा, राइट? उसके बाद आता है पेज रिप्लेसमेंट एल्गोरिदम. Okay, page replacement algorithm that we have seen. Just what is page replacement algorithm? So again, it's a concept of paging where we are dividing the process, right? And we are bringing that pages into the main memory. So again, when we are bringing into main memory, we are not bringing all the pages at once, right? We are bringing some pages of a process, so but we are providing a illusion, that is virtual memory concept, that complete process is in execution phase. That means complete process is in your main memory, right? So again, if that means we are swapping some pages from main memory to secondary memory and secondary memory to main memory. So हम ये करते हैं. So again, so that means which if you are swapping out from the main memory to secondary memory, अगर ये सब हो रहा है, right? So there should be some algorithm to do so, right? There should be a way, right? So we have seen FIFO in division 2, while in division 1 it is yet left to do. Okay, so today we are just going to see recently used two other algorithms, and for division 1 I will be taking it in the next lecture. FIFO will be taken in the next lecture, right? So just to s- start with, okay, that is page replacement algorithm. Okay, in that there are three commonly used page replacement algorithm, that is FIFO, first in first out. Okay, then optimal page replacement, and the third one is LRU, least recently used, right? So ये डिवीजन 1 में बाकी है, okay, and 2 में done है. Okay, so starting from least recently used algorithm. Okay, if I state in one line, if I state in one line, what does it says that replace the least recently used page in past. Okay, so let's say again starting giving a broad definition कि ये मेरा main memory है. Okay, just suppose this is my main memory, and suppose that I am having only capacity of 4 pages, 1, 2, 3, and 4. Okay, so this is my let's say first, second, third, and fourth page. Okay, ये मेरे अलग अलग frames है. This is my main memory, and this is my these are my different frames. Now, even in exam and even for consideration or understanding this particular algorithms, page replacement algorithms, we are having a reference string. Reference string is nothing but sequence of pages which are going to come. Okay, sequence of pages which are going to come, or which CPU is going to demand. Okay, in short, CPU ये demand करता है, which CPU is demanding. So reference string का मतलब क्या है? पहले let's say if I am writing like this, so 7, 0, 1, 2, 0, 3, 0, 4, 2, 3. Okay, so these are the reference strings. मतलब क्या कि ये this are the pages which is demanded by CPU. Okay, तो ये sequence में मेरे पास pages आ रहे हैं CPU के पास से. So what will happen when I will be using least recently page used algorithm? Okay, so at this start there is no page present. Okay, and CPU has demanded 7. तो होगा क्या? पेज फॉल्ट. सो दिस इज द फर्स्ट इंस्टेंस ऑफ टाइम, और यहाँ पे होता है पेज फॉल्ट. ओके, ये मेरा फर्स्ट इंस्टेंस ऑफ टाइम है. इधर आप ये वाली देखो तो अब ये दिस इज टाइम. ओके, टाइम ग्राफ में मेन मेमोरी में क्या हो रहा है. ओके, एंड दिस आर दी अदर एम्प्टी. ओके, उसके बाद सीपीयू ने मुझे मांगा जीरोथ पेज. सो अगेन देर विल बी अ पेज फॉल्ट. तो 7 तो ऑलरेडी मेन मेमोरी में है, एंड देन 0. सो क्या हुआ? फर्स्ट इंस्टेंस ऑफ टाइम को भी when 7 was asked, पेज फॉल्ट हुआ. सेकेंड टाइम भी पेज फॉल्ट हुआ. नाउ द थर्ड टाइम when CPU is asking for the next page. Okay, for the CPU is asking for the next page. तो 0, 7 is already there, again 1. so उसके लिए वापस पेज फॉल्ट होगा. Okay, and for 2 also page fault होगा. So this is again a page fault, this is again a page fault. ये मांगा, उसके बाद ये मांगा. Now in the next turn, what is our 0? Okay, the next is 0. So 0 is already there. 0, 7, 0, 1, 2, and here we got a hit. That means already मेरे main memory में वो है, page है, right? 0 page है, right? So we got a hit. Now what we are asking for, हमको यहाँ पे एक hit मिला, right? Now next page is 3. Now, next page is 3. That means we are again having a page fault. तो अब कौन सा पेज रिप्लेस होगा? That is the decision which we need to make. That's the decision which we need to make. Right? So, ये जो अब ये चार जो pages हैं, that is 7, 0, 1, 2, which is the least recently used. मतलब और रिसेंटली कौन सा नहीं यूज हुआ है. सो इफ यू से सो 2, ओके, 2 इज हियर, 1 इज हियर, 0 इज हियर एंड 7 इज हियर, और हम अभी यहाँ पे हैं, राइट. सो रिसेंटली कौन सा पेज इसमें से यूज नहीं हुआ है? दैट इज 7, राइट. सो 7 विल बी रिप्लेस्ड 3, 0, 1, 2. I guess 7 will be replaced in a place, and page 3 will be loaded there. Okay, 7 will be replaced. So हमारा जो replacement हुआ वो कहाँ पे हुआ? वो हुआ यहाँ पे, ठीक है. Okay, वो हुआ यहाँ पे. So this was a page fault. Again next, see I am going too slow, right? So please pay attention कि क्या हो रहा है एक एक step में, right? Concept is easy. Okay, so next again it is asking for 0. So again that is a page hit. यानी कि हमें page fault नहीं हो रहा है, so that's a good thing. Page hit हुआ. Okay, and then next. अब आया 4. So again we need to have what? We need to replace. We are having a page fault और हमें replace करना पड़ेगा. तो हम ये केस में कौन सा पेज रिप्लेस करेंगे? 0 अभी रिसेंटली यूज हुआ है, उससे रिसेंटली 2, 1, 0, 3, 2 और 1 है जो सबसे पीछे यूज हुआ है, राइट. 1 इज द विच वाज लीस्ट रिसेंटली यूज. दैट मींस 1 रिप्लेस होगा. सो व्हाट विल हैपन? 3, 0, 4, 2. रिप्लेस क्या हुआ? यहाँ पे रिप्लेसमेंट आया. ओके, रिप्लेसमेंट यहाँ पे आया. ओके, नेक्स्ट, सॉरी, next. Again that's there is 2, so already page hit होता है. Okay, उसके बाद 3 है. 3 के लिए भी पेज हिट होगा एंड 0 के लिए भी पेज हिट होगा. ओके, एंड वापस 3 आया. Again for that you will have a page hit. For 2 also you will have page hit. 4, 0, 3. ओके, इसके लिए भी पेज हिट हुआ. नाउ 1. सो 1 के लिए क्या होगा? पेज फॉल्ट. अगेन देयर इज अ पेज फॉल्ट. सो कौन सा पेज रिप्लेस होगा? So 2 is here, 3 is here, 0 is here and 4 is here. So fourth page replace होगा, right? So again 2, 0, 1. ये किसके लिए हुआ? पेज हिट, पेज हिट, पेज हिट, 201, राइट? यहाँ पे हमारे पास ऑलरेडी है। उसके बाद क्या आया? 7। उसके बाद क्या आया? 7। अगेन वी नीड टू रिप्लेस, तो 201 तो अभी यूज हुआ है, तो थ्री विच इज रिसेंटली यूज, 7012। पेज कहाँ रिप्लेस हुआ? यहाँ पे रिप्लेसमेंट हुआ। Okay, and here we got a page fault. And for again then 012, we are going to have, okay, page hit. That is for this. Okay, so this is how your page replacement algorithm works. This is how your page replacement algorithm works. So any doubt till here? It's a simple concept, right? And I was taking the sum too slow, so I hope it's feasible, right? It's understandable. Okay, so अगर ये so this is the scenario. Okay, so if this is a scenario, तो यहाँ पे uh, what will be the page hit? कितने पेज हिट हुए यहाँ पे? पेज हिट मतलब ये जो मैंने टिक मार्क किया है, जहाँ पे हमें हमारा पेज मेन मेमोरी में मिल गया था. Okay, so I guess that is 12, and page fault were 8. Okay, so hit ratio, and in exams mostly you will be asked what is the hit ratio. So a hit ratio होता है 12 by 10, 12 by 20. Okay, because there were total 20 pages, 20 calls of the pages, right? 20 times calls किया CPU ने, and in that we got 12 time hit. That means 60% we got hit ratio, right? Hit ratio was 60%.
But
So
isn't that too low? Like, ठीक है मतलब एग्जाम्पल के लिए like what is the ideal value?
obviously it is low, और लेकिन हम जो एग्जांपल देख रहे हैं, हम वहाँ पे ये भी देख रहे हैं that we are having only 4 frames, right? That means 4 pages. So if you think that hit ratio 60% है, actually in real life also, if you see that hit ratio is 70% to 80%. Even in this example, even if you think in the practical life, the hit ratio whatever they are using the 70 to 80%, because they are majorly using optimal page replacement algorithm. Okay, uh, optimal page replacement algorithm be, but major it is not even optimal page replacement algorithm, but they are using some hybrid structure of this nowadays. Okay, but basically these are the 3 types. There are actually many types, but जब मैंने बोला कि common types है ये 3, it's like in practical life they are using some combination of these 3 versions.
Ah, so like they tried and tested and their course corrected accordingly.
It's not always trial and tested. मतलब कि ये जो भी बनता है, we are seeing with this example, but जब कोई algorithm बनता है, they are using a very extensive level of mathematics. दे आर यूजिंग अ वेरी हाई कैलकुलेशन. हम इसे समझने के लिए 4 पेज के लेवल पे देखते हैं. दे विल बी हैविंग सम ऑप्टिमल नंबर ऑफ दिस, मतलब ये नंबर्स कितने होने चाहिए, देन और व्हाट इज द ऑप्टिमल नंबर ऑफ द नो स्वैप इन एंड स्वैप आउट, उसका एक रिसर्च होता है, एंड देन दे आर यूजिंग दिस. सो इफ यू If you think कि कैसे ये बना होगा, then it's a very depth of it's inside the very depth of maths. क्योंकि हम उसमें postulates लेते हैं अलग अलग कि क्या what were the different postulates, what were the different scenarios, and then on based on that they are developing it. But हम जब समझते हैं कोई algorithm, we are understanding it in very uh, layman language or very easy way. Okay, but जब ये बनता है then at that time it is very difficult. But yeah, again 60%, if you think that's a bad ratio, even here in real life I have not heard 70 to 80 more than 70 to 80%. So ये लो कहना तो बुरा होगा अभी के खिलाफ, अभी के सिनेरियो में इट्स नॉट टू लो. But yeah, again the market
And
is
sir,
open to
glad
optimize
that
it.
glad that you brought these things up. What is like the eureka moment for like these stuff? So like when do these scientists say that okay, here we are with another better efficient codes and things like that? If you could elaborate on that part as well, would be great.
Hello.
Yes, sir. Was my question audible to you? Like,
नो, मैंने खाली इतना सुना कि कौन सा एल्गोरिदम पहले आया, ये आप कुछ सब पूछ रहे हो.
no, no,
Uh,
no. It isn't like which algorithm came first. The question was that what is like the eureka moment that they say that okay, this newer algorithm has arrived, which is better enough, like compared to the previous ones. So, like, if you could elaborate on that part.
really, I haven't studied the history in that way. But if you are even interested in that part, you can look into the books. But I really do. For मैं कोई गलत आंसर नहीं दूंगा, lame आंसर या कुछ भी बना के. Really, I haven't seen into that because that was not in my interest. कि कौन सा algorithm आया, because I haven't dived into that. Frankly saying, अगर आप जानना चाहते हो, then I will bring it to you. In next
Okay,
session,
sir.
I will definitely bring it to you.
Okay, sir.
Okay. So this is what your least recently used algorithm says, right? So the second thing which we can see in this particularly page replacement algorithm. Yeah, before discussing that, डिवीजन वन में भी फीफो नहीं चला है बट डिवीजन टू में चल गया है. सो देयर इज वन थिंग दैट फीफो यूज मतलब कि वो ज़्यादा यूज में नहीं है, तो इट वाज बेस्ड ऑन द ऑब्जर्वेशन दैट द पेज विच इज नॉट रिसेंटली यूज्ड is used very in it is not used in much frequency. The frequency of that page must be less. ओके, जो पेज अभी रिसेंटली यूज नहीं हुआ है वो पेज मोस्ट फ्रिक्वेंटली यूज नहीं होता होगा, इसलिए वो अभी यूज नहीं हुआ है, राइट. सो वी नीड टू वी आर रिप्लेसिंग दैट पेज. LRU was based on is based on that theory. While when we are talking about MRU, ओके, सो ये ऐसा कहता है कि जो अभी यूज हुआ है पेज, लेट्स से इफ आई हैविंग 4023, राइट. सो जो अभी यूज हुआ है, देयर आर वेरी लेस चांसेस दैट इन नियर बाय फ्यूचर वी आर गोइंग टू आस्क फॉर द सेम पेज. MRU इज बेस्ड ऑन दैट. जबकि LRU क्या बोलता था कि 40123, दैट जो बहुत टाइम से पेज यूज नहीं हुआ है, देयर आर लेस चांसेस दैट इन नियर बाय फ्यूचर इट विल बी आस्क्ड. Okay, there are less chances that in nearby future it will be asked. While MRU is saying जो भी बहुत recently use हुआ है, there are very less chances that उसको CPU call करेगा nearby future में, right? So these are the two thought process between LRU and MRU. Okay, so let's have a sum on MRU also, but this is a basic theory, or you can say अंडरस्टैंडिंग कि ये दो कैसे एग्जिस्टेंस में आए. ओके, सो दिस इज बेसिक नॉर्मल थियरी और अंडरस्टैंडिंग दैट व्हाट वाज द थॉट प्रोसेस बिहाइंड दिस. सो MRU, so again, if you take example of MRU, let's have reference key that is 701. A reference key, matlab this is our page calls, right? I am taking the same page sequence. Okay, so this is most recently frequently used. So again, this is our main memory. Okay, I'm just doing it now in one go. Okay. Now I'm not showing step by step. I hope it's now understandable कि कैसे जा रहा है. Okay. So again, for first instance 70 ये तो same ही रहेगा. Okay, so for this we got page fault, page fault, page fault, right? So these are the different page faults. So starting में जब हमारा main memory empty है तब, then we got page hit 2107 for 0. Now we are having 3, right? We are having 3. So अब in the case of least recently used, हम क्या करते हैं? हम 7 को replace करते हैं. ओके, लेकिन फॉर इन द केस ऑफ मोस्ट रिसेंटली यूज, मोस्ट रिसेंटली कौन सा यूज हुआ है? 0. तो हम 0 को रिप्लेस कर रहे हैं. सो व्हाट विल हैपन? 2137. ओके, 2137. सो दिस विल बी योर पेज फॉल्ट. ओके, so solve this sum and tell me what is the hit ratio. Okay, I think you won't take much time. Okay, tell me what is the hit ratio. Fatafat. Done. Anyone have done this? किसी ने किया solve? What is the hit ratio and page fault here? Hello.
Yes, sir.
So what is the हो गया तो hit ratio और page fault क्या है? What is the hit count and hit ratio or what is the page fault here? Okay, I hope you must be doing or you must have done. Okay, so here in this example, you will get hit as 8 and page fault equals to 12. Okay, okay. So anything you would like to ask now? कोई और चीज? Sorry, any doubt till here? Concept were very easy, right? But any doubt till here? कुछ पूछना है? Anyone?
No, sir, no doubt.
Okay. So we can keep it till here. Okay. And in the next lecture, we will see optimal page replacement algorithm और division वन के लिए FIFO भी देखेंगे. And here, after completing this, we will move to the next topic. Right. So for today, this much is enough. Okay. So we can meet in next lecture. If anyone would like to ask anything, they can ask. If you're copying from the board, if you want to copy the sum from the board, then you can do that also. And keep it open for 3 to 5 minutes. And but if you are done, then you can leave.